And we're back to conclude 19-2, where we're discussing hydrogen ions and acidity. In this last podcast of this section, scrolling all the way down to the last page of this section of notes, what we're going to do is we're going to give you 4 solutions. And we're going to tell you either the hydrogen, the hydroxide concentrations, either the pH or the pOH, and we want you to be able to calculate the other parameters and determine whether or not the solution is acidic, basic, or neutral. So let's go ahead and do letter A together, where we give you the hydrogen concentration being 2.0 times 10 to the negative third molar. Now, there are lots of different ways that you can tackle this. I'm going to show you the way I would tackle this, but if you have a different way that you think might work, feel free to give it a try, and then you can ask and say, is this fine? All right, so what I would do first, if I know the hydrogen concentration, I'm going to go directly to pH, because that equals the negative log of that hydrogen concentration. So that'll be the negative log of 2.0 times 10 to the negative third. And we know this is going to be right around 3 because this is a negative 3. And in fact, if you do that calculation, that's going to be 2.70. All right. Now the next thing I would do is I would determine the pOH, because I know that the pOH, pH plus pOH equals 14. So if the pH is 2.70 plus the pOH is going to be 14, when I subtract that over to the other side, minus the 2.70 minus 2.70, the pOH then must be 11.30. Put a little cloud around that, since that's the answer there. And we'll do the same up above, right there. And then from that, I would go back and calculate the hydroxide concentration. The hydroxide concentration is going to be, well, I'm going to use this little equation up here as we were discussing hydroxides. And let's keep scrolling, keep scrolling. I'm going to use this equation right here. Now, by the way, you don't have to have the pH, pOH, or these relationships memorized. We'll let you write those down. You just need to be able to use those. And so pOH then is going to be 10 to the negative, I'm sorry, the hydroxide concentration will be 10 to the negative pOH, which means it's going to be 10 to the negative 11.30. And if you just type that into your calculator and expand it, allow it to perform the calculation, it would be 5.01 times 10 to the negative 12. And that, of course, is molar because it is a concentration. There are no units for pH and pOH. They are unitless numbers. But the hydroxide is a concentration, so it's going to be in molar. All right. So let's go ahead now and try solution B, where we're giving you the hydroxide concentration is 5 times 10 to the negative 4 molar. Now, again, whenever I'm given a concentration, I go directly to the p-values, the pH or the pOH, because they're very easy to calculate and move back and forth. So what I would do is say that the pOH then is going to be the negative log of the hydroxide, which would be 5.0 times 10 to the negative 4. Of course, the pOH is going to be right around 4 because the exponent is a negative 4, but it's going to be a little bit less than that. And in this case, it's going to be 3.30. So that is the pOH. Now I can easily calculate the pH because I know that pH plus pOH is going to have to equal 14, so therefore pH plus 3.30 equals 14, and therefore pH, when I subtract this over to the other side, is going to be 10.70. So there you go. And finally, to calculate the hydrogen concentration will be equal to 10 to the negative pH. So that will be equal to 10 to the negative 10.70. And when I just type that into my calculator, I get 2.0 times 10 to the negative 11 molar for the hydrogen concentration. Alright, so we'll put a cloud around that. Oh, we didn't say whether or not these solutions were acidic, basic, or neutral. Let's just finish up letter B here. Because the solution has a pH that's greater than 7, this solution must be basic, based on the pH. However, you could also compare the hydroxide to the hydrogen. The hydroxide is greater than the hydrogen, so that also makes it basic. If you go back here to letter A, and I'm going to put a cloud around this since that was our hydroxide answer. Since the pH is less than 7, we know that this solution is acidic. And we would know that as well by comparing the hydrogen to the hydroxide. Because the hydrogen is greater than the hydroxide, it is in fact an acidic solution. Alright? So if you want to pause this, you can go ahead and try to tackle letter C and D on your own, and then we can get back together and compare some notes. Okay, so now letter C. We are given a pH of 4.63. I know that the pOH will be 14 minus the pH, or you can say pH plus pOH equals 14 and then move it over. That would be fine. So therefore 14 minus 4.63 is going to give me a pOH equal to 9.37. Now I already know the acidity or basicity of this thing, but we'll go ahead and finish up the hydrogen and the hydroxide first. The hydrogen will be 10 to the negative pH, while the hydroxide will be 10 to the negative pOH. Let's go ahead and finish this one up first. We have 10 to the negative 9.37, and when I perform that calculation, I'm getting 4.27 times 10 to the negative 10 molar for the hydroxide. And for the hydrogen, it's going to be 10 to the negative 4.63, which when we perform that calculation is 2.34 times 10 to the negative 5 molar. Now we know that this solution is going to be acidic because the hydrogen is greater than the hydroxide, or you can just look at the pH. It is less than 7, so this solution is definitely acidic. And we'll put one more cloud around that just to be consistent. And finally, given a pOH of 7, we know that the pH is going to also have to be 7 because the pH plus the pOH equals 14, or I can rearrange the equation like so. So 14 minus 7 is in fact going to be 7. And since the pH is 7, I already know that this thing is going to be neutral, but we'll go ahead and finish the calculations. This is 10 to the negative pH. Whoops. And where'd we go here? Alright, there we go. So we have 10 to the negative pH, which is going to be equal to 10 to the negative 7, which does not have to be expanded. You can write that as 1.0 times 10 to the negative 7. That would be fine. And you would get the exact same thing for the hydroxide, 10 to the negative pOH, which means this is 10 to the negative 7, which equals 1.0 times 10 to the negative 7 molar hydroxide. And I forgot the molar for the hydrogen. So we've calculated that. We have calculated this. We have calculated this value. And of course, because the pH is equal to 7 and because the two concentrations are the same, the solution is neutral. Alright? So, in this section we've taken a look at the equilibrium that lies between hydrogen and hydroxide in water. We've calculated pH, pOH, hydrogen and hydroxide concentrations, and also determined acidity, basicity, and neutrality. That concludes 19.2.